second episode of Current Build. This is a series where I'm going through and I'm going to be building some of my side projects in public. So today I get to talk about one of my absolutely favorite AWS tools, and that's AWS Textract. AWS Textract is a tool for extracting text from images. So there's a lot of really neat things you can do with Textract, and so we're going to talk about some of those today. So if you weren't here, I was on vacation last week. It was my sister's wedding. It was absolutely gorgeous. It was great to relax and not do any coding for a week. But I'm back at it now. But 2 weeks ago, I introduced the current project we're working on, and that's Bits to Bytes, which is a virtual sous chef that helps you give you cooking advice and also kind of creates grocery lists for you from images of those grocery lists. So what I want to do today is give you another demo refresher of Bits to Bytes and show you where Textract fits into that process. And then we're going to look at Textract itself, look at how it works, some of the different features within Textract, and then we're going to actually write some code to use the Textract API using Python. So let's get into it, starting with a quick refresher of Bits to Bytes. So like we discussed last time, Bits to Bytes is a messaging bot to help with your various different cooking needs. And one of those features is it actually helps you create a grocery list. So I can say, text, I'm in Facebook Messenger, create grocery list, and the bot will be like, great, I can do that for you. And the next thing we need to do is send an image. So this is actually from last night. Skinny Taste is one of those recipe websites we use all the time because she has phenomenal recipes. So I think we're making some kind of chimichangas this week. And so what happens is the bot takes the image of the recipe, it does all the processing, and it extracts out the recipe ingredients for you. But the question is, how do you start with an image like this and get to the list of recipe ingredients down here that the bot sends out? We talked a little bit about that process last week at a high level, but now let's look at each of the individual components. So the very first step, once the backend, that serverless framework in AWS receives that image, the very first thing it does is it has to be able to extract the text out of the image so that we can do all the NLP and all the other processing to pull out the recipe ingredients later on. But the first piece is being able to get the text from this image. And so that's where AWS Textract comes into play. So now let's look at Textract itself. I'm in the AWS console here, and I'm going to go up to Services and type Textract, and we'll see Textract's right here. And this is going to take us to the Textract product page. So AWS Textract, Amazon Textract, is a OCR tool. OCR stands for Optical Character Recognition. It's a tool to help that optical character recognition is really the fancy way of saying being able to extract text from an image. There's a lot of different OCR tools. Pretty much every cloud provider is going to have some form of an OCR product. I know Google has Textract. Microsoft has a similar product as well. I'm just blanking on the name right now. But all these tools are around being able to extract text and data from documents. These could be PDFs, these could be images, whatever it might be. So it's a really powerful way of digitizing physical media. So what's nice is within Amazon, they have this nice Try Amazon Textract button. And what this does is it shows you a sample document on the left, which is a employment application. And on the right-hand side, it gives you a flavor for the some of the output that Textract can do. We're going to go through some of these output options here. But the first piece of output is just raw text. And with raw text, all Textract is doing is taking your input document here, and it's identifying all of the words and lines in the document. So for example, employment application, applicant information, you can see how the text is represented on the left, and then on the right is the output from Textract, full name, the phone number, previous employment history, etc. You can see how this works. So Textract in the raw text provides two different types of output. The first is what's here, which is lines of text, where you can see all the text that appears on the same line, reading left to right, is grouped together. So employment application is one piece, applicant information is all one component, previous employment history is all one piece of the Textract output. But one thing Textract does do when creating that output is we looked at this line right here with start date, end date, employer name, position held, and reason for leaving. Notice how each one of these are separate pieces of output. And that's because Textract does, when you're playing with the line level output, Textract will provide these separators. So if there's a large space, like there is a larger space between some of these words here, it will consider them to be their own component. And so that's why we're getting separate output for these pieces of text here, even though they are on the same line. The other form of the output is you can get the individual words for the output as well. So before we had on the line output, we had employment application all as one line, but now they're broken out into individual words. Same thing with applicant information, and then the previous employment history. You can see that all of the text extracted here is broken up and parsed into all the individual words. There's a lot more of data generated by Textract that we're going to get into when we do our kind of live coding. But this is a good representation of how Textract works. And this is the form where actually go back to the lines, and we're going to be working mostly within this framework with the line level output, and we'll look at that again when we get to the API coding. Textract does have a couple other features. So one is the ability to extract data from forms. So for example, with this employment application, Textract can go notice that there are kind of forms where the user is prompted, or there's a field of information the user needs to fill in. So in this case, it's full name, phone number, home address, and mailing address. And what Textract can do is recognize that there are these fields of data that are being asked to be filled out, and Textract will actually provide that information in the output as key value pairs. So in the output, full name would be the key, and the value would be Jane Doe. So it's able to pick up the nuances of these forms, these form type these fields in the form, I should say, and provide that back to you, so that when you're processing the data, you can easily see that on this employment application, the full name is Jane Doe, their home address is this 123 Any Street, their phone number, and their mailing address. So Textract has that ability to transfer forms into these key value pairs in the output. The other piece of output is Textract can process tables for you. So if your document has a table of data, with Textract, it'll actually break that table into columns and rows to make it easier to access. So that you understand that all of these different data types are related to a single table within your document. So those are the three main functions of Textract: getting the raw text, being able to process the forms, and then processing tables. So I'll show you. We're going to focus on this raw text piece here for the in our API code when we get to the API coding next, but I'll show you as we walk through the API how you can access the API to do the form and tabular processing as well. So that's a really quick overview of Textract using the console. Now let's go over to a Jupyter notebook I'd set up that we're going to use to walk through some of this code. So in order to use Textract, we're going to be using the Boto 3 library. And Boto 3 is the AWS Python developer kit. It gives you really access to all of the different APIs for interacting with the AWS services. So let's look at what version so for this I'm going to be using version 1.14.39, which I believe is the most up-to-date version as of today. If not, it's a very recent version for Boto 3. So one of the nice things I like about Boto 3 is it has very good documentation for using the different services that Amazon provides. So this is the documentation page for Textract, and this explains all the different methods available for you, and we're going to be looking through some of these in more detail here. But the first thing is, the first task we need to do is actually initialize the client for accessing Textract, which is this line of code right here. So I'm going to put this here, and so this is just a so we want to initialize the Textract client here, and that's done. And let's look at some of the methods available with the documentation. So the first one I want to look at is this one here, analyze document. So remember I said there were three different forms of output. There's the raw data, the raw text, forms, and table. If you have data that's going to have either forms or a table in it in your document, you will use the analyze document method, because that is the method that will give you that form and tabular data. We aren't going to be doing anything with the form and tabular data, but I just wanted to let you know that if this type of data is in your document, use analyze document. If you just have text, if you just want raw text from your document, and this is the method we're going to be using, it's the detect document text. So detect document text will basically take your input document, whether it's an image or a PDF or whatever it ends up being, and it will identify all the different blocks of text in the document. It'll give you all the different lines of text, pages, and words of text as the output. And so this is what we're going to be using, detect document text. And with detect document text, we really only need to provide a document as a parameter, which is right here. You can see in the request syntax. So with Textract, you can provide a document two different ways. You can either provide a document as point to a S3 object with the bucket and the name of the file, or you can use a kind of bytes encoded document that maybe you have stored locally or whatever it may be. So you can specify a document either way, but that's actually the only parameter that we need to set. So let's take follow this request syntax, and let's look at each one. So I started, so let's do the S3, because this is a little bit more straightforward. So I have a document stored in S3. So we do client So we're gonna call the detect document text and pass this S3 object as the document we want to process with Textract. So we take the Textract client here, we call the detect document text method, and the parameter we have to set is document. And the document is going to be an S3 object. And again, we have to define the S3 object with a bucket. And a name of the object. In this case, I believe it's image1. Okay. Let's run that. All right, and then let's just make sure we got a good response. So we can look at the response, and there's a lot of information here, and we'll get to that here in a second. So let me. But that's how you call the use Textract as when you have a document in S3 that you want to use. It's pretty straightforward. You just need to define your document as an S3 object, provide the bucket here, and then provide the name of the object you want to read, the document you want to read. So now use a document converted to bytes. So you may not always have your document stored in S3. You may be working off some local files, and that's okay too. Textract has a way for you to interact with to send documents as bytes. So in this case, let's say I have a local image. Let me write out the path here. So this is actually coming from the one of the images I used to train the NLP. So it's let me get the whole path right here. So that's a path to a local image I have stored on my computer. So what we need to do is open the image and convert it to bytes. So let's open the image path. Raw image.read. Read the image in, and then convert it to bytes. And we can just call the byte array on that temp image for reading it in. Okay. So this block of text I just wrote is going to going to open that image file, convert it to bytes, and now we can call the Textract client with the bytes image as input. So response equals and now this time we set the document parameter equal to bytes, and then we send in the bytes image. And this will take a second. There we go. And then we can look at, just pop open that response, and we can see we got a bunch of output here, which is good. Oops. Okay. Get rid of that for now. Okay. So that's the difference. I mean, those are really the only type of parameters you need to define to use this detect document text. If you're using S3, define your document as an S3 object with the bucket and the kind of name of your document within the bucket. If you have a local image or you have a local document that you want to parse, you have to convert it to bytes first, and then send the bytes object as a parameter where you've defined the document as being of a bytes type. Okay. So now let's look at the response some more. What you get back from Textract. So as we can see, there's a lot of information within the response. So let's start breaking this apart. So we can see that the response is really just a JSON object. And if we head over back to the documentation, it actually provides a very detailed response syntax of what you get back from Textract when you parse a document. So there's going to be a handful of pieces of information. So the first is document metadata. So we can go over here, and this is really just going to be basically the number of pages detected in the document. So if we go look at response document metadata, in this case we sent an image, so we're going to get back one page. Detect document text model version is the version, I think that's just the version of the API, which is 1 if I'm not mistaken. Yeah. So and then, yeah, that's just 1. And the response metadata has some information about your request made. Headers, request IDs, when it was, length of the content, all that kind of stuff. But the main piece of information is in blocks. This blocks component has all of the key information that we want to look into. So let's separate the blocks. Hang on a second. My wife locked herself out of the house. I'll be right back. All right, sorry about that. My wife left to go to the gym and then realized that she had locked herself out of the house. So, taken care of. So what I'm doing here is I'm just creating kind of a variable to hold all the blocks objects, and then we'll take a look. So at the type. So blocks is a list. Each item in the list is going to be an object defining a block of output. So if we look at the length of blocks, we'll see there's 204 different blocks of text in the output. And so let's look at that first block. So each block is going to define a block type, and it's also going to provide a lot of detailed geometry information to define where the block of text was identified. So the first block type here is just a page, and so this just tells you, what, and also lists the relationships. So in this case, it's going to tell you all the different lines of text within the page. So let's look at some other types of output we get. So counter oops. So in this image, we have one page, one image, one page, 27 lines of text, and then 176 individual words. So actually, I should show you that image right now. So I mean, this is the image that we're looking at. It's a recipe for some type of salad with peanuts, so you can see, this is the text. Well, we're going to look at the text in a second here, but this is what the recipe looks like. So what we're going to do next is, since we have, the blocks have a lot of information here. So if we go look at another block of our output, let's go to 1. We can see that this is a line, and when we start getting into the lines and the words, we start to get some additional keys in our output object. One being the actual text. So in this case, the text is with peanuts. So we go back and look at our image. That's the top title of the recipe we're looking at here. We also get this confidence field here, which the confidence is the AWS level of degree of confidence that they've correctly converted they've correctly translated the words, or not translated, but they've extracted the correct words and also the correct location for the words. So this will be between 0 and 100. So 94, pretty high confidence here for this piece of text. And then the geometry, it can be used to draw out the bounding box, the coordinates for where the text is located. So I don't know if you've done some image processing before, but these bounding boxes, all of the coordinates will range from 0 to 1. If you're used to working with pixels, these aren't pixels. They're going to be 0 to 1. So just know that when you're building these bounding boxes, and that Textract will scale the bounding boxes to be within this 0-1 piece. All right. And then each object gets its own unique identifier, and then again the relationships. In this case, a line. These child objects are going to be the words. So with is one of these, and then peanuts is another. So when I'm working with, let's look at one more. That's not a very good one to look at. That's not either. I'm trying to find a. And now, if we go to look at another block, we get a word. This is a word type. Notice the text is this one word, dark, and we get all the same type of information. Note the only difference here. Notice when you get to the word level, you don't have any of those child relationships in the output. So when I'm working with bits to bytes, I like to use the lines because when we looked at the going back and we looked at the Textract console output, we noticed that when Textract is parsing the lines, it does give you it does break lines out by if there's a tab space. So I like to work with the lines, and that's what we're using on bits to bytes. So we'll get all the lines of text from the image. So let's call a new variable all lines. Blocks if L block type equal line. So we have this a list of all the lines now. We can see there's 27 of them. And what's nice is when we look at one of the lines of text, the text is peanuts, bounding box. But one of the nice things is now we can say in all lines, let's just print out all the different all the 27 lines of text. So there they are. So we can print out all the lines of text here. And notice that this is starting to look a lot like a recipe. When we compare it to the recipe text itself, we can see that what Textract is providing us here is very similar to what's in the recipe. And what's also really nice about this with the Textract is with the recipe we have this kind of separation of the ingredients into two different columns. And Textract is actually picking up that separation within its output. So we can see that we have there are separate lines for the 3/4 ounce dried branch, and then the 5 ounce red skinned are kind of separated out on different lines, which is good. That's the desired output. But the one piece here that we talked about last time is, although Textract does a good job of identifying the actual text from the image, we can look at this. We can look at this reading left to right, top to bottom, and notice that some of these lines are not combined correctly. So for us, again, reading left to right, top to bottom, we have the 3/4 ounce dried branch, and then 5 ounce red skinned, and then string lettuce or 5 dark peanuts. It's not ordered correctly. So if we go back to the recipe image, and we can see that from our perspective as humans, we're able to notice that everything on the left-hand side here is kind of related to one another. And then on the right-hand side, that's a separate list of ingredients that we need to keep separate and we need to group correctly. Textract won't do that for us. Textract is just pulling out the lines of text. So what we need to do next is we need to be able to utilize some of the other Textract output to combine these lines in a logical way that we can put into our NLP. So what we need to do is process these lines in a way that we are maintaining the textual relationships of the columns. So we want all the text for this column on the left, and then all the text for this column on the right to be combined together, so that we're capturing the context for these relationships. But that's not going to be something for today. That's where we're going to pick up next week and really start working with the geometry components of the Textract output. So kind of just to review today, Textract is a really useful tool for extracting text from images or other documents. So I really hope you go play around with it, try something new. It's all you have to do is download the Boto 3, initialize your Textract client, and then pass in an image or a document either in S3 or as this bytes if it's a local document or stored someplace else, and you get your output. So, my mouse is not cooperating. Okay. So that's it for today. I hope you found something helpful here. Please go try Textract. I think it's a really fun tool. I use it for a lot of different applications in a couple of different projects, not just this one. So yeah, if you do play around and use Textract in some interesting way, tell me about it on Twitter at Matthew Vielkind. And yeah, let's talk about it. I love to see what other people are doing. So that's going to be it for this episode. So next week, we're going to take that raw Textract output, those lines, and we're going to talk about a way to process it to get the data in a format that we can use for NLP. So that's going to be really exciting. This is also going to be one of those learning in real time type moments too. So come join me next Tuesday morning, and we'll talk about processing this Textract output to kind of keep building out this project for you. So thanks for joining. I will see you all next week, and have a good one.